on whiteboard, go ahead and write probability. All right, so we're going to start off with this problem right here. So it says if you throw a six-sided die 120 times, how many times would you expect it to land on a factor of 24? What do we need to know in order to understand this problem? Good. How many factors are there? So we've got a six-sided dice, and we've got the numbers 1, 2, 3, 4, 5, and 6, right? Go ahead and write the ones on your whiteboard that are factors of 24, ones that we can multiply to get to 24. Well, you should have circled 1 times 24 is 24. 2 times 12 is 24. How about 3? Is 3 a factor of 24? 3 times what equals 24?
8.
3 times 8 equals 24. 4 times equals 24. So that means 6. What about 5? Nope. Okay. So if I broke my whole here of a dice into 6 pieces, what is the probability that I would land on a factor of 24? Yes, 5 out of 6. That's right. Go ahead and write that right underneath there. So we've got 5, 6 is the probability of landing on a factor of 24. If you throw a six-sided dice 120 times, how many times would you expect it? So what's 5, 6 of 120? Okay, what strategies are you thinking about right now? What are you thinking? Good, so I've got 120 as my whole, right? My 100% right here. And I need to break it up into 6 pieces. Good, so then I need to, so 120, let's use our extended facts right here. 120 divided by 6, I know 6 times 2, it gets me 12. So how many times does 6 go into 120? That's right, 20 times. So that means each 6 is 20. And just like our friend was saying, we needed to multiply the size of 1/6 times the number here, right? So we had 5, 6, or 20 times 5. So I've got 5 times 2 is 10, plus 1, 0 right there. So what is 5, 6 of 120? 100. If we're thinking about relate this to discount number stories, in a way, we've got our whole 120, and I could have just subtracted 1/6 to know that my 20 times 5 then was 100 then. So how many times would you expect to land on a factor of 24? 100 times if we ended up rolling it 120 times. Good job, guys. This is just practicing the expected outcomes and thinking about rates. So let's try another one. Go ahead and erase your board. This one is very similar. This one says, if you throw a dice 36 times, how many times would you expect 4 to come up? So first thing we need to do is figure out what is the probability that I land on 4? 1/6, right? Because there's only 4. If I took my dice and I broke it up into 6 pieces, and I've got 1, 2, 3, 4, 5, and 6. There's only 1 4 on there, right? So 1 out of 6. So what's 1/6 of 36 then. Same strategy, right? Take my 36, divide it into 6 pieces. What is 36 divided by 6? Yes. 6, right? So we've got our whole 36. So 1/6 then is how many, friends? 6. So 1/6. That's pretty easy on that one. Okay, let's go ahead and move on to this next one. This time I'm going to ask you to design a spinner so that the probability of landing on red is 1/4, blue is 3/8, yellow is 1/4, and green is 1/8. What problem do you see right there as we begin to set up our spinner? What do you see? Right, it's an unfair spinner, isn't it? Now, how can I compare 1/4 and 3/8? How can I compare 1/4 and 3/8? How can I decide the size of those pieces? 1/4 and 3/8. It's a problem right there. Yeah. Yeah, our denominators are not the same. So we can make them equal, the denominators the same. Should I change it to 8s or 4s? What do you think? You want me to change it to 8? So how many 8s is equal to 1/4? 2 8s. So let's change this. So that means design a spinner so that the probability of landing on red is not 1/4 but 2/8, right? Blue is 3/8. Yellow is 1/4 is equal to how many 8s? 2/8. And then green is 1/8. So I'm going to be breaking up my spinner into what's my denominator then, friends? 8s. So the way I do that to keep myself organized is I go in half, and then I've got fourths, and half of a fourth is an 8, right? So now I've got red, which is 1/4. And how many 8s was that? 2 8s, so I've got 2 that are red. Blue is 3/8. Yellow is 1/4, so how many 8s is that? 2 8s. And then our lowly green, just 1/8. So what's the likelihood that I'm going to land on green? The likelihood. That's right, that's the probability I'm going to land on green 1/8 of the time. Is that likely, unlikely? Unlikely, right? Which one is the one I'm most likely to land on? Blue. What's the probability of landing on blue? 3/8, right? 3/8 on that one. Good, good. All right, guys, rock and roll today. I'm going to throw one more at you. Okay, so this one says if you tossed a coin on the grid below, what fraction of the tosses would you expect to land on P? Well, what's our hole right there? 4ths, right? So how many P's are there? 2. So we've got 2/4. That's right, or half. What's the percentage on that, friends? 50%. That's right. So then my next question then says, at this rate, which means each time I throw it, I expect it to land half of the time. 50% of the time, right? How many times would she land on P if she tossed it 100 coins? So again, we're thinking about what's 50% of 100. That's right, 50, right? All right, friends, you can go ahead and say goodbye.